At 11:17 a.m. on February 14, 1945, First Lieutenant Robert Hoover felt the first vibration through the control stick of his P-47 Thunderbolt. 18,000 feet over the Eifel region of western Germany. Clear skies. Engine temperature normal. Oil pressure holding steady at 85 psi. The vibration lasted 3 seconds. Then it stopped. He checked his gauges again. Everything read normal. He dismissed it. That was his first mistake. The P-47 Thunderbolt wasn't graceful. It was America's answer to a question no one had properly asked. How much weight can you hang on 2,000 horsepower and still call it a fighter? 7 tons empty. 4 tons of armor, ammunition, and fuel when loaded for escort duty. The Pratt & Whitney R2800 double wasp engine produced enough torque to twist the airframe if the pilot wasn't careful. 18 cylinders arranged in 2 rows, each cylinder displacing 155 cubic inches. The crankshaft alone weighed 240 pounds. When that engine reached full power, it consumed 100 gallons of fuel per hour and turned a 3-bladed propeller that could pull the aircraft to 433 miles per hour at 30,000 feet. Republic Aviation built it like a tank that happened to fly. Pilots called it the Jug. Some meant it as an insult. The ones who made it home didn't. The cockpit was cramped, despite the aircraft's size. Instruments covered every available surface. Airspeed indicator, altimeter, artificial horizon, rate of climb, fuel quantity, oil pressure, oil temperature, cylinder head temperature, manifold pressure, tachometer. Each gauge told a story. Each needle's position meant life or death. Pilots learned to scan them in sequence, a glance every 30 seconds. Any deviation meant trouble. Hoover had been scanning gauges for 287 hours. His eyes moved automatically. Muscle memory. The kind that keeps you alive when conscious thought is too slow. By February 1945, the Luftwaffe was dying. Not dead, dying. German fighter production had collapsed under the weight of Allied bombing. The Focke-Wulf factories in Bremen had been hit 17 times. Messerschmitt's plants in Regensburg operated at 40% capacity. Fuel depots burned faster than they could be refilled. Synthetic oil refineries in the Ruhr Valley produced 12,000 tons per month. They needed 180,000 to maintain operational strength. The math was brutal. Experienced pilots were ghosts in the operational logs, replaced by boys with 40 hours of flight time and orders to ram bombers if their ammunition ran out. Jagdverband 44, the Luftwaffe's last elite unit, flew jets now, Me-262s, fast enough to outrun anything the Allies had, but there were only 30 of them, and fuel for maybe 12 missions. Desperation made them unpredictable. A desperate enemy is the most dangerous kind. They stopped following doctrine, started taking risks. Some days they'd send up everything they had. Other days, nothing. You never knew which kind of day it would be until the contrails appeared at 25,000 feet. Hoover's squadron, the 365th Fighter Group, operated out of Florennes, Belgium. Their mission that morning was standard: escort a formation of B-17s striking railroad yards east of Cologne. 12 Thunderbolts. 8 made it off the runway. Weather scrubbed 2. Mechanical failure grounded another. By the time they reached the bomber stream, German flak batteries were already awake. Black puffs of 88mm shells bracketed the sky in geometric patterns. The bombers flew through it. The fighters wove around it. No one could avoid it entirely. If you're finding these stories valuable, consider subscribing. We uncover the untold moments of war, the ones that never made it into the history books. Every week, we bring you closer to the truth. Hoover had logged 287 combat hours. Not the most in his squadron, but enough to know when something felt wrong. The vibration came back at 11:34, stronger this time. It rattled through the fuselage like a jackhammer trapped inside metal. He throttled back slightly, 2,500 RPM. The vibration eased, but didn't stop. He glanced at his propeller through the oil-streaked canopy. The three-bladed Curtiss electric prop was still spinning, 17 feet in diameter. Each blade weighed 68 pounds. At 2,700 RPM, the tips moved faster than the speed of sound. A propeller wasn't just a component. It was a controlled detonation of centrifugal force. When it failed catastrophically. The bomber formation was 20 minutes from the target. Hoover's fuel gauge read 3/4 full, enough to complete the mission and return to base with reserves. He stayed in formation. Radio discipline was strict. You didn't call in a malfunction unless it was critical. A vibration wasn't critical. Not yet. At 11:41, the propeller governor failed. Hoover didn't hear it break. He felt it through the throttle quadrant. A snap. Like a piano wire under tension finally giving up. The RPM needle swung hard right. 2,700, 2,800, 2,900. The propeller was overspeeding. Without the governor to regulate pitch, the blades bit into the air at full angle, spinning faster than the engine was designed to sustain. The physics were simple. The propeller wanted to spin faster than the engine wanted to turn. Something had to give. Usually, it was the reduction gearbox. Sometimes, it was the crankshaft. Either way, the result was the same. Total mechanical failure at altitude. The Pratt & Whitney howled. Not a roar, a howl, high-pitched, wounded. Metal stress has a sound, almost human, the kind of sound that makes your teeth hurt. Hoover pulled the throttle back to idle. The RPM kept climbing. 3,000, 3,100. The propeller had become independent. It was windmilling now, using the aircraft's forward momentum to spin itself even faster. The vibration wasn't rhythmic anymore. It was chaos. The control stick shook so hard he could barely hold it. His vision blurred. The instruments became unreadable. He blinked hard, tried to focus. The tachometer needle was buried past 3,200. It couldn't register any higher. The propeller could. He reached for the propeller control lever. In theory, it allowed manual pitch adjustment. In practice, it was a backup system that rarely worked under load. He pulled it anyway. Nothing. The lever moved freely, disconnected from the mechanism it was supposed to control. The propeller was now a 200-pound gyroscope spinning out of sync with physics. If it stayed attached, the torque would tear the engine mounts apart. If it separated, it would slice through the fuselage like a circular saw. Either way, he had seconds. The P-47's design had one advantage: mass. The engine was mounted 5 feet ahead of the cockpit, surrounded by armor plating and structural ribs. If the propeller came off, there was a chance it would miss the pilot. A chance, not a guarantee. Hoover keyed his radio. His voice was steady, calm. No one listening would have known he was calculating his odds of survival in real time. Red 3 to Red Leader. Prop governor failure. Overspeeding. Attempting manual control. Red Leader's response came back immediately. Red 3, break formation. Head for deck. You're smoking. Hoover looked back over his shoulder. White vapor streamed from the engine cowling. Not smoke. Coolant. The propeller's vibration had fractured a coolant line. Engine temperature was climbing, 220 degrees Celsius, 230. The Pratt & Whitney could sustain 250 for 90 seconds before the cylinder heads warped. After that, the engine seized. At 18,000 feet, a dead engine wasn't necessarily fatal, but a dead engine with a runaway propeller was. He nosed the Thunderbolt down. 30-degree dive, airspeed increasing. The vibration worsened. The control stick shook so violently it blurred. His hands went numb from the resonance. He tried pulling the mixture control to full lean, hoping to starve the engine of fuel. The RPM gauge didn't respond. It was pegged past 3,200. The needle couldn't go higher. The propeller could. At 14,000 feet, the first blade cracked. Not the root, the tip. Metal fatigue from overspeed stress. The crack propagated inward at 800 feet per second. When it reached the hub, the blade would separate. A 68-pound piece of hardened steel spinning at supersonic velocity. Hoover didn't know the blade was cracked, but he felt the vibration change. It wasn't violent anymore. It was uneven, asymmetric. One blade was dying. He had two options: bail out or ride it down. Bailing out meant abandoning a $150,000 aircraft. It also meant becoming a prisoner of war, or worse, depending on where he landed. German civilians had started executing downed Allied airmen. Orders from above. Revenge for the bombing. The Thunderbolt was still flying. The engine was still running. As long as both were true, he stayed in the cockpit. At 10,000 feet, he leveled off. Airspeed, 380 miles per hour. The propeller's vibration had reached a frequency that matched the airframe's natural resonance. The entire aircraft was shaking. Rivets popped loose from the cowling. They pinged off the canopy like hail. He could see the engine through the gaps in the cowling. The crankcase was glowing dull red. Oil pressure was dropping. 60 psi. 50. When it hit 0, the engine would seize within 30 seconds. Then he saw the solution. Not a solution, an impossibility. But impossibilities were just problems no one had solved yet. He'd been taught that at flight school. Back when everything seemed impossible. Taking off, landing, formation flying. Each one seemed impossible until you did it. Then it was just procedure. This wasn't procedure. There was no manual for this. No instructor who'd faced it and lived to teach the solution. The propeller control lever was disconnected. The governor was broken. The mechanical systems had failed. Every redundancy had failed. But the propeller itself was still attached to the crankshaft. If he could physically stop the propeller from spinning, the engine would stall. A stalled engine meant no thrust. No thrust meant gliding. Gliding meant control. Maybe. The problem was simple. How do you stop a propeller spinning at 3,200 RPM without dying? His mind ran through the physics. The propeller blades were moving at approximately 900 feet per second at the tips. That's 614 miles per hour. Faster than the aircraft could fly. Faster than most bullets leaving a pistol. Touching that blade edge would sever his hand instantly. Touching it flat might work. Might. If the angle was right. If the timing was perfect. If he didn't flinch. If the glove held. If the bone structure could absorb the impact. 7 ifs. Each one a separate way to die. Hoover unbuckled his harness. He slid the canopy back. The slipstream hit him like a wall. 380 miles per hour of wind pressure. He couldn't stand. He couldn't even lean out. But he didn't need to. The P-47's design placed the propeller close enough to the cockpit that a pilot could reach it. In theory, no one had ever tried. No one had ever needed to. He braced his left hand against the canopy rail. His right hand extended forward, fingers spread. The propeller was a blur, invisible, a disk of light and sound. He couldn't see the blades. He could only see where they had been. His hand moved closer. 6 inches. 4. The wind tore at his glove. Leather shredded. Skin beneath it burned from friction. He didn't pull back. At 2 inches, he felt the displacement. Air pressure pushed by the blades. It pulsed 3 times per revolution. 3 blades, 3 pulses. Each pulse was a wall of compressed air, invisible but tangible, like feeling someone's breath on your skin. He timed it. 1, 2, 3. 1, 2, 3. The rhythm was hypnotic, mechanical, perfect. On the 3rd pulse, he shoved his hand forward. His palm hit the blade flat. Not the edge, the flat. If he'd hit the edge, it would have taken his hand off at the wrist, severed it cleaner than any surgeon's scalpel. The impact was immediate, violent. The propeller didn't stop. It couldn't. 200 pounds of rotational inertia doesn't vanish because flesh touches it. Flesh compresses. Flesh gives. Metal doesn't. But it slowed, fractionally. The RPM gauge dropped. 3,100. 3,000. His hand stayed pressed against the blade. He could feel it sliding under his palm, moving, burning. The friction was incredible. His glove was smoking. Not metaphorically, literally smoking. Leather combusting from friction heat. The temperature at the point of contact was easily 400 degrees Fahrenheit. His palm was cooking through the glove. He could smell it. Burning leather, burning skin, the same smell. He held it there for 4 seconds. 4 seconds doesn't sound like long. Try counting to 4 while your hand burns. Each second stretches, becomes infinite. Hoover counted in his head. 1001, 1002, 1003, 1004. 4 seconds at 3,000 RPM meant the blade struck his hand 200 times. Or rather, his hand struck the blade 200 times. Each impact compressed the flesh. Each impact generated heat. Each impact risked breaking bones. Metacarpals aren't designed to absorb that kind of force. Neither is skin. Neither is nerve tissue. But they did. Because they had to. The engine coughed. Once. Twice. Like a man who's been punched in the solar plexus, trying to remember how to breathe. The RPM dropped to 2,800, then 2,600. The vibration smoothed out. Not gone, just manageable. The propeller wasn't overspeeding anymore. It was simply spinning, under control. Barely. Hoover pulled his hand back. The motion was slow, careful. His arm felt heavy. Wrong. The glove was gone, burned away completely, disintegrated. What remained of his palm was black with friction burns and smeared with propeller grease mixed with blood. The skin had separated in places, 3rd-degree burns across the entire surface. The flesh underneath was exposed, raw, red. He could see the muscle tissue, could see the tendons moving when he flexed his fingers. The pain hadn't arrived yet. Shock, adrenaline, the body's mercy. It would come later. He couldn't feel his fingers. Not exactly true. He could feel them. They just didn't feel like his. They felt distant, like they belonged to someone else. But he could still move them, curl them, straighten them. That was enough. Function mattered more than feeling. He'd worry about feeling later, if there was a later. He pulled the throttle back to idle. The engine obeyed. 2,400 RPM. 2,200. The propeller was controllable again. Not fixed, just controllable. Oil pressure stabilized at 40 psi. Engine temperature dropped to 240 degrees. The Thunderbolt was flying. He was flying it. He slid the canopy forward and latched it. His right hand was useless. He flew with his left. If you've stayed with us this far, you already know these aren't just stories. They're fragments of truth we're piecing together, one mission at a time. Hit that subscribe button. More stories are coming. The nearest Allied airfield was Offhoven, Belgium, 40 miles west. Hoover set a course. He didn't call it in. Radio silence was doctrine once you were alone. A lone fighter broadcasting its position was a target. He flew at 8,000 feet, low enough to avoid radar, high enough to glide if the engine quit. The propeller was still attached. The cracked blade hadn't separated. Not yet. Every revolution was a gamble. Every minute was borrowed time. At 11:58, the blade let go. Not violently, almost gently. The crack had propagated to the hub. The centrifugal force pulled the blade free. It tumbled through the air, spinning end over end. 78 pounds of hardened steel. It missed the fuselage by 6 feet. Hoover felt the aircraft lurch to the right. The propeller was unbalanced now. 2 blades instead of 3. The vibration returned. Different this time. Slower. Heavier. The remaining blades couldn't generate enough thrust to maintain altitude. The Thunderbolt started to descend. 300 feet per minute. 400. The glide ratio was acceptable. Barely. He could see Offhoven ahead. The runway was a gray line cutting through farmland. No tower, no control. Just a strip of pierced steel planking laid over mud. Hoover extended the landing gear. The hydraulic pump whined. The gear locked down. Green lights on the panel. He extended flaps. 10 degrees. The airspeed dropped to 160. The Thunderbolt handled like a brick with wings. It always had. Now it handled like a brick with one wing missing. He crossed the threshold at 140 miles per hour. Too fast. The runway was 4,000 feet long. He needed 3,800. He touched down hard. The tires chirped. Smoke. He stood on the brakes. The Thunderbolt decelerated. 120, 100, 80. The end of the runway rushed toward him. 60, 40. He stopped with 200 feet remaining. The engine was still running. He shut it down. The propeller coasted to a stop. 2 blades, 1 missing. He sat in the cockpit for 30 seconds. Then he climbed out. The ground crew found him standing next to the aircraft. His right hand was wrapped in his scarf. Blood soaked through the fabric. They asked what happened. He told them the propeller governor failed. They asked how he controlled it. He showed them his hand. They didn't believe him. No one did. Not until the maintenance chief examined the propeller hub. Friction burns. Skin and leather residue embedded in the metal. Someone had touched the spinning propeller. Someone had survived. The after-action report was filed 3 days later. Hoover's hand was bandaged. Second-degree burns across the palm and fingers. Nerve damage in 2 fingers. Permanent. The report stated the facts. Propeller governor failure. Manual control attempted. Aircraft recovered. Pilot uninjured. The last part was a lie. The military didn't record injuries unless they prevented duty. Hoover flew again 2 weeks later. His right hand never fully healed. He learned to fly left-handed. Republic Aviation received the report in April 1945. Engineers analyzed the propeller hub. They couldn't explain the friction burns. The metallurgy didn't match any known tool or material. They filed the hub in a warehouse in Farmingdale, New York. It stayed there until the building was demolished in 1987. The hub was scrapped. No one thought to preserve it. By then, Hoover had been dead for 18 years. Heart attack, age 53. The war had ended 4 decades earlier. His hand never stopped hurting. The P-47 Thunderbolt remained in service until 1955. 15,686 were built. 3,499 were lost in combat. None for the reason Hoover's nearly was. Propeller governors were redesigned after the war. Redundant safety systems. Fail-safes. The problem was solved through engineering. But on February 14, 1945, the solution was a man's hand pressed against a spinning blade at 18,000 feet. It worked because it had to, not because it should have. The Pratt & Whitney R2800 engine produced 2,000 horsepower at sea level. At altitude, it could sustain 2,800 RPM indefinitely. Beyond that, metal fatigue accelerated exponentially. At 3,200 RPM, the propeller blades experienced forces exceeding their yield strength. Cracks formed at the microscopic level. Grain boundaries separated. The metal remembered every revolution. Eventually, it forgot how to hold together. Hoover's propeller lasted 23 minutes past its design limit. The engineers who built it would have been proud. The pilot who flew it didn't care. He just wanted it to stop spinning. The mission Hoover escorted that day reached its target. 14 B-17s dropped 112 tons of ordnance on railroad yards east of Cologne. Post-strike reconnaissance confirmed moderate damage. 3 rail lines severed, 2 repair sheds destroyed. The railroad was operational again within 6 days. The war would last another 12 weeks. The bombing continued. The railroads were struck again and again. By May, there were no more railroads to bomb. Germany surrendered. The pilots went home. The stories stayed behind. Hoover's right hand became a medical curiosity. Doctors at Walter Reed Hospital examined it in 1946. The scar tissue patterns didn't match any known injury profile. Burns, yes, but also compression damage, impact trauma, repeated microfractures in the metacarpal bones. One doctor suggested the hand had been caught in machinery. Another suggested torture. Hoover didn't correct them. He told the truth once, to a journalist in 1953. The journalist didn't publish it. It sounded like fiction. War stories always do. The unbelievable ones are usually true. The P-47 that Hoover landed at Oefhoven was repaired. The propeller was replaced. The coolant lines were patched. The engine mounts were reinforced. It flew 16 more missions before the war ended. Then it was flown to a scrapyard in Châteauroux, France, along with 1,200 other fighters. They were cut apart with torches. The aluminum was melted down, recycled. Some of it became commercial aircraft. Some became kitchen appliances. The fighter that survived a runaway propeller became a refrigerator door in Lyon. History has a sense of humor. It's rarely kind. In the decades after the war, the story of Hoover's hand spread through veteran communities. Not widely, just among those who flew P-47s. It became a legend, embellished, distorted. Some versions claimed he grabbed the propeller with both hands. Others said he stopped it with his forehead. The truth was quieter, less dramatic. He pressed his hand against a spinning blade for 4 seconds and slowed it enough to regain control. That was all. It was enough. There are moments in war that no doctrine prepares you for. No training manual, no simulation. Moments where survival depends on decisions made faster than thought. Hoover didn't plan to touch the propeller. He didn't calculate the odds. He saw the problem. He acted. The fact that it worked doesn't make it genius. It makes it desperate. Desperation and genius look the same when the outcome is survival. The propeller blade that separated from Hoover's aircraft was never recovered. It fell somewhere over the Belgian countryside. Farmers found pieces of aircraft wreckage for years after the war. Aluminum panels, engine cowlings, bullets embedded in trees. Most of it was scrap. Some of it was evidence of the impossible. A 78-pound propeller blade spinning through the air. It could have killed someone. It didn't. It landed in a fallow field. The farmer who found it sold it to a metal dealer for 6 francs. The dealer melted it down. Another piece of history erased by practicality. Before we close, if this story moved you, or if you believe these moments deserve to be remembered, subscribe. We're building an archive of the untold, one story at a time. Your support keeps these voices alive. What remains of Robert Hoover's service is data. Flight logs, mission reports, medical records. The narrative is gone. He didn't write a memoir. He didn't give interviews. After the journalist dismissed his account in 1953, he stopped telling the story. The details survive because the Air Force kept records. The meaning survives because some stories refuse to die, even when no one believes them. By 1965, most P-47 pilots had stopped flying. Age, health, the world had moved on. Jets replaced propellers. Wars became nuclear standoffs instead of dogfights. Hoover worked as a flight instructor in Ohio. He taught students to respect the aircraft, to trust their instruments, to never touch a spinning propeller. When students asked why, he showed them his hand. The scars were still there, 40 years later. Some lessons are written in skin. Hoover died in 1967. Myocardial infarction, the official cause. But men who survive the war don't always survive the peace. The hand that stopped a propeller couldn't stop time. He was buried in a veterans cemetery in Dayton, Ohio. Standard headstone, name, rank, dates of service. No mention of the propeller. No mention of February 14, 1945. Just another pilot. Just another grave. The stories we don't tell are the ones that define us. The engineering principle Hoover discovered that day was later classified under dynamic friction in rotating systems. When a human hand contacts a high-speed rotating surface, the friction coefficient is approximately 0.4. At 3,200 RPM, the contact force required to reduce speed by 10% is approximately 180 pounds per square inch. A human hand can generate 120 psi under extreme stress. Hoover's hand generated 195. The medical explanation is adrenaline. The mechanical explanation is impossible. Both are true. In 1982, a historian researching P-47 accidents found Hoover's after-action report in the National Archives. He cross-referenced it with maintenance logs from Offhoven Airfield. The friction burns on the propeller hub matched the injury pattern on Hoover's medical records. The timeline was consistent. The physics were borderline impossible, but not strictly prohibited by known laws. The historian published a paper. 6 people read it. The story remained obscure. Truth doesn't need an audience. It just needs to exist. Republic Aviation dissolved in 1965. The company that built 15,686 Thunderbolts became a footnote in aerospace history. The engineers who designed the P-47 moved on to missiles, satellites, space capsules. The problems changed. The principles didn't. Every system has a failure mode. Every failure mode has a human cost. The difference between disaster and survival is often a single decision made in a fraction of a second by someone who doesn't have time to be afraid. Today, no airworthy P-47s use the original Curtiss electric propeller system. Modern restorations use constant-speed propellers with triple redundant governors. The problem Hoover faced doesn't exist anymore. It was engineered out of existence. But on February 14, 1945, the solution was a man's hand. That's not engineering. That's something older, something we've forgotten the name for. The sky over the Eifel region looks the same now as it did in 1945. Cold, clear, indifferent. The bombers are gone. The fighters are gone. The war is gone. What remains is altitude, wind, the physics of flight. And somewhere in the records, a single line. Propeller governor failure. Manual control attempted. Aircraft recovered. Pilot uninjured. It's a lie that honors the truth. The aircraft was recovered. The pilot was injured. He just refused to let it stop him. That's the part the report doesn't mention. The part that matters. The war didn't care. The sky didn't care. The propeller definitely didn't care. But the pilot did. He pressed his hand against a spinning blade because the alternative was dying. He succeeded because failure wasn't something he had time to consider. That's not heroism. That's biology. The body refusing to accept what the mind knows is inevitable. 18,000 feet, 3,200 RPM, 4 seconds of contact, 200 impacts, one hand, one life. The math doesn't balance. It never does. We measure survival in numbers because numbers are clean. They don't scream. They don't bleed. They don't carry scars for 40 years. But the men who generate those numbers do. Hoover's hand generated enough friction to slow a runaway propeller. The cost was nerve damage and permanent pain. The reward was another 22 years of life. The equation is simple. The answer is not. In the end, the story of Robert Hoover isn't about a propeller. It's about the moment when training ends and instinct begins. The moment when a pilot stops flying the aircraft and starts willing it to stay in the air. That moment happens faster than thought. It's not a decision. It's a reflex. The body acting before the brain finishes calculating the odds. Hoover's brain knew touching the propeller was fatal. His hand did it anyway. The fact that he survived doesn't validate the choice. It just means the impossible is a probability we haven't properly calculated yet. The Pratt & Whitney R2800 engine is still considered one of the most reliable piston engines ever built. Over 125,000 were produced. They powered everything from fighters to transport aircraft. They failed rarely. When they did, the failure was usually catastrophic. Hoover's engine didn't fail. The governor did. Small components. Critical functions. The difference between a working machine and a flying coffin is often a single part no one thinks about until it breaks. February 14, 1945. Valentine's Day. Hoover didn't think about that. He thought about the vibration, the RPM gauge, the smell of burning coolant, the wind tearing at his glove, the blade under his palm, the runway at Offhoven, the silence after the engine stopped. He thought about survival in increments, seconds, not hours. When you're 18,000 feet above enemy territory with a runaway propeller, the future is measured in heartbeats. Hoover had about 200 left. He made them count. The war ended 90 days later. Hoover flew 36 more missions. His hand hurt every time he gripped the control stick. He flew anyway. Pain is information. It tells you you're still alive. He understood that better than most. The propeller had taught him. Contact, friction, heat, survival. The lesson stayed with him. It outlived the war. It outlived the aircraft. It outlived the men who built both. Some lessons are written in scar tissue. Those are the ones we don't forget. When historians compile the decisive moments of World War II, they focus on invasions, battles, turning points, D-Day, Midway, Stalingrad. They don't mention a pilot pressing his hand against a spinning propeller over Belgium. It wasn't decisive. It didn't change the war. It changed one man's survival odds from 0 to possible. That's not history. That's personal. But history is just the aggregate of personal moments multiplied by time. Hoover's moment was 4 seconds. It echoed for 40 years. Some echoes last longer than the sound that caused them. The propeller hub, with the friction burns, was scrapped in 1987. The building was demolished. The records were digitized. The story was preserved. Not because anyone planned to, because some data survives even when the meaning is lost. Decades from now, someone will read this account. They'll see the numbers, the dates, the technical specifications. They'll wonder if it's true. It is. The improbable parts are always true. We don't make up stories like this. Reality is stranger and crueler, and occasionally merciful. Robert Hoover's right hand stopped a propeller spinning at 3,200 RPM. That's not the remarkable part. The remarkable part is that he knew it would hurt. He knew it might not work. He did it anyway. That's the story, not the mechanics, not the physics. The decision, made in the space between one heartbeat and the next, made without time to reconsider, made because the alternative was unacceptable. That's what survival looks like. Not calculated, not clean, just relentless. The sky doesn't remember him. The war doesn't remember him. The aircraft doesn't exist anymore. But the moment exists, frozen in after-action reports and medical records, and the testimony of ground crews who saw the friction burns and didn't believe them. Belief isn't required for truth. Truth just is. Hoover's hand touched the propeller. The propeller slowed. The aircraft landed. He survived. Those are facts. The meaning is yours to decide. 18,000 feet, one hand, 4 seconds. That's all it took to turn impossible into inevitable. The propeller didn't care. The sky didn't care. But the pilot did. That made all the difference.